Okay, so let's begin. So what upthrust was is we know that whenever something is submerged in a liquid, that there is always an upward force on that object that is submerged, right? So for example, if you submerge this block into a liquid, okay, now we know that if this block is submerged in a liquid, then there is going to be some volume of the water that is displaced, right? So the volume of the water that is displaced is equal to the volume of the block which was fully submerged, right? So this is, one note that you should remember. Now, if you remember pressure in fluids, you remember that pressure is equals to rho gh, right? That at a higher depth, you have a higher pressure due to the fluid, right? And that means if you have, what would be the pressure at the top part of the block? That would be P1, which is equals to rho gh with the height h1. Okay. And what would be the pressure at the bottom part of the cube? That would be P2, which is rho gh with the height of h2, or depth of h2. Now, you see that because there is a smaller pressure at the top, there would be a smaller force at the top, right? And at the bottom face, because there's a greater pressure at the bottom, there would be a greater force at the bottom, right? Now, that means if you take the upward forces, right, from the top, they would be equal to this value. So P1 is equals to rho g h h1, right? And we also know that pressure is equals to force over area, right? So if you want to find an expression for force, then F1 is basically equal to this expression, right? Where, if pressure equals to force over area, I took area on the other side, and F1 is equals to this expression. Okay. Then what about F2? At F2, because the pressure is higher due to a larger depth, right? The force must also be higher, right? If the pressure is higher due to a greater depth, then the force at the bottom face should also be higher, right? So P2 is equals to rho gh2, and rather than writing pressure, I've written it in terms of forces, right? Because that's what we want to solve for. So F2 is equals to rho gh2 into A. Yes. Any problems up to this point, Abhiya?
No.
No, all good. Okay. Yes, Abhiya, Kaima. All good up to this point. How we made this expression?
Yes.
Yes. Okay. Now,
Wait, so F2
yes.
is supposed to be
Hmm.
higher than F1, right?
Yes, it is always going to be higher than F1 because do you see that in the expression you have height h2 for F2 and height h1 from h1. H1 is the height or depth from the top, which is always going to be smaller than the depth of the bottom face, right? Because whenever you
Yeah.
submerge something, the bottom face is always at a greater depth and the top face is always at a smaller depth. And because of that depth difference, the downward force, or the force at the bottom face, is always going to be higher, because since h2 is always greater than h1, that means that f2 will always be greater than f1, right? Why is f2 greater than f1? Simply because the pressure at the bottom face is higher than at the top face. So if you summarize all of that, okay, I'm going to start from here now. Okay, yes. So, hmm. So if you summarize all of the facts, right, we know that there is a small force F1 at the top face. And what is that force F1 equal to? We figured out that that force was equal to what value? That was equals to rho fluid into G into H1 times A naught. Okay. And there is going to be a force at the bottom face as well. And this bottom face force is always going to be higher because it's at a greater depth. And F2 should equals to density into fluid into G into H2 times A naught. Okay. Now, because, because since F2 is always greater than F1, right? If F2 is always greater than F1, that must mean there will always be a net upward force. There will always be a net upward force, right? And this net upward force, this F2 minus F1, this net upward force is basically what we call upthrust. Upward force is what we call upthrust. Okay, we haven't, formed a general formula for upthrust yet, but this is just the expression that we've made. We're going to, simplify this very complicated expression in just a second. Okay, any problems up to this point? That what is the origin of upthrust? That because of, because in fact, let's write down a question. It often comes up. Explain the origin. Explain the origin of upthrust. So, for example, there's a past paper question multiple times that they ask you to explain the origin of upthrust, and it's a 3 mark question. That means they want you to explain it in detail. I write it down, and it'll clear things up even more. Okay, so there'll be multiple points for this. So, first of all, what you say is that uh, hmm, how do I start? Hmm, the pressure at top face of submerged object is due to depth h1. Okay, then pressure at bottom face is at depth h2. Right now, in liquids we know that as depth increases, pressure increases, right? And that means if pressure is higher, that must mean force must be higher as well, right? Now, because since at greater depth, force is sorry, pressure is higher, that must mean force is higher, right? So this means then bottom force must always be higher than uh, top face force. And if you take that resultant, right, if you subtract the bottom force and the upward force, the net force is basically equal to that value, right? So bottom F2 must always be higher than the top face F1. So that means if you take F2 minus F1, this is equal to the upthrust. That is equal to what upthrust is, that there will always be an upward net force because of the pressure differences. Okay, so if you were to explain upthrust in a single line, if you were to define upthrust in a single line, or 1 mark, that means yes. So upthrust, how you would define that is that this is the net upward force on an object submerged submerged in a fluid due to due to pressure difference between depths. Okay, so because of the different depths, there's a different pressure at the top and the bottom, and because of the different pressure at the top and the bottom, there's a different force, and because there is a difference in the forces, that must mean there must always be a net upward force. Okay, now, so let's generalize an expression for upthrust. Now, we know from this expression, okay, this is an important one. We know that upthrust is basically just the difference of these forces. Upthrust is basically equal to F2 minus F1, right? Because it's the difference of these forces that is causing a net upward force due to being immersed in the liquid. Now, what is F2? That is density of fluid times G into H2 times A naught minus density of fluid into G into H2, H1 times A naught, right? So, do I see everything common? I do. Everything else is common except heights. So that means if I could do density into fluid into G into A naught as common, what is left? All that's left is It's just H2 minus H1, right? It's just H2 minus H1. That's all that's left because I took rho G A naught common in both of them. So all that's left is H2 minus H1. Okay. Now, if you remember, what volume was, what was volume? I'm sure I told that earlier. Volume is always just area times the height, right? And isn't this basically area times height? Because what was H2? H2 was this distance. H2 was this distance. And H1 was this distance, right? So if you subtract H2 minus H1, doesn't that leave you with this H? Because H2 was the depth of the bottom from the top, and H1 was the depth of the top part from the from the top part. Now that means if you do H2 minus H1, that is basically this value. H2 minus H1 is this is the height of object. This is height of object. Okay. And if you remember, volume is simply area times the height of something, right? So that means if you multiply area times height, this means that this is just equal to the volume. So that means F upthrust is basically equal to density of the fluid times G times the volume. That's it. And this is the formula for upthrust. This is the formula for upthrust. And now be very careful of this formula. This is the volume of object submerged. Submerged is very important. Submerged is very important, right? So that means in this formula, you substitute how much of the block is submerged, right? So for example, if all of it is submerged, then you're going to use the volume of the entire cube. But for example, if only a portion of the cube is submerged, that means you're only going to use that portion. Okay. Now, another very interesting thing. That's, basically what we call as Archimedes principle. Now, interestingly, this is the volume of the object submerged, and it is also equal to the volume of fluid displaced. Volume of fluid displaced, right? Because the object, where is it? Where is it? Okay, I'll write that down later. So this volume, this V, right? This V is basically equivalent to the volume of the object that is submerged, and it is equal to the volume of the fluid that is displaced. Now, so that means F upthrust is equals to density times density of the fluid times G times Vf, right? Now this Vf could either be the volume of the object that is submerged, or it could be the volume of the fluid that was displaced because of submerging that object. Okay. Now you can say another thing from this expression. Sadly, I understand there are so many equations over here, and don't worry, they're all connected at the end. Now, what was density? Density is equals to mass over volume, right? And do you know that mass is density times volume, right? It's density times volume. Now, doesn't that mean, do you see that density and volume is over here as well, right? So that means if you multiply them again, what does this become? This was density of the fluid, right? And what was Vf? That was the volume of the object that was submerged, or it was the volume of the water that was displaced. So doesn't that mean density into volume is basically mass of the fluid times G? So that means another thing, that upthrust, this is Archimedes principle, that upthrust, F up, is equal to the weight. F is equals to mg, right? Weight is equals to mg. F upthrust is equal to the weight of the fluid displaced. No, it takes a bit of imagination to understand this. I'm going to send you a very interesting video after this to actually understand what this means. Okay, I am going to leave you here for 5 minutes. Okay, try to write it down, try to absorb it. I'm going to ask questions after 5 minutes. Okay, if you have any questions, ask away, and I'll guide you through it. The only way you understand this is if you try to imagine stuff and you try to write it down by hand and you ask questions. There is no other way. Okay. Even if you seem absolutely clueless, that's fine. It's understandable. Even the first time I studied, it took me some time to absorb it. Okay. I'll be right back in 5 minutes. Yes, Ariz. Questions? Yes. What's up?
I understood it.
Understood it? Okay.
Yeah.
Yes, Hanya. How you doing?
Yeah, I'm good. I have a question
Hmm.
with
Yes.
yeah, for like the last equation that you formed about
Hmm.
force upwards,
Hmm.
you mentioned that like it's equal to the weight of the fluid displaced. So
Hmm.
like, does that mean the upthrust is always equal to the weight, like in all the cases?
Yes. So that means now I'm getting to the your question exactly the way you asked it. Okay. Now, Kaima and Biha, do you have any other questions?
No.
Okay. Now, yes. So this means what we've learned from this is that the upthrust on an object that is immersed is equal to the weight of the fluid that was displaced. Okay, so that means, for example, let's take this object. Okay, and when I take this object, that means when I immerse this object in the fluid, that means that the volume of that water is going to rise, right? So this is equals to V times F, and it is also equals to Vf of the object that was immersed, right? So both the object and the object that was submerged and the fluid that was displayed. Vf is what? This is the volume of fluid displaced. Okay. And this is equal to the volume of the object that was submerged. Okay. Now, the idea of upthrust is what we learned from the equation above is that the value of upthrust, right? If you remember, upthrust was always, pointing upwards. So the value of upthrust is always pointing upwards, right? We learned that earlier as well. Let's say this is 5 newtons. Okay. Now, what this equation is telling me is that this force of upthrust is equal to the weight of the water that you have displaced. This is what Archimedes principle is, right? So that means you had this 5 Newton force upthrust, right? So 5 Newton was equal to upthrust on the block. Okay. This was equal to upthrust on the block. Now, the alternative explanation is, upthrust, where does that come from? We see that if you take this water, right, the volume of the water that was displaced, the weight of this fluid, right, the weight of this fluid, mf times g, which is equals to the weight of fluid that was displaced, they are both equal. The weight of that means if you weigh this water, the weight of this is 5 newtons, and coincidentally the value of upthrust on this object is also 5 newtons. So that means this was Archimedes principle, that I'm going to write it down so you absorb it into your head, that the weight, so basically F upthrust, or F upthrust is on an object submerged is equal to the weight of the fluid displaced. The weight of the fluid displaced. That's basically Archimedes principle, right? So that means if the value of upthrust on this block is 5 newtons, that means if you weigh the water that you have displaced, that weight would also be 5 newtons, right? So F upthrust is equals to rho F times G times volume F, right? Now, this means that if you multiply density and volume of the fluid together, then you get F upthrust is equals to mass of the fluid times G, right? From this expression, you see that F upthrust is the upward force on the block, right? This is the upward force on the block, right? And by definition, we see that is also equal to the weight of the fluid displaced. That's basically Archimedes principle. Fluid displaced. I'm going to show you an animation to better understand it.
Sir,
Yes. Yes. What's up?
sir, by weight
Hmm.
of water displaced, you
Hmm.
mean like only a part of the water, or
Yes.
like
Yes.
the entire?
Displaced. That's why I wrote displaced. That means, for example, this water, the volume that was increased because of adding the object.
Okay. Okay. Yeah, I
Okay.
understand.
Okay. Now I'm going to show it to you so you can learn it intuitively. And I'm also going to send you a video after the class. Make sure you watch it. It's an excellent demonstration. Okay. Okay. Now, check this out. So, at the moment, I want you to read two things. First of all, check the volume of the water. Uh, where is it? Huh. The volume of the water is 100 liters. Okay. And and the weight of the object is 19.6. Okay. Now check this out when I drop it into water. Okay, if I drop it into water, first of all, notice what is happening to the volume of the water. Volume of the water increases by 2 liter. Okay. Now, if you check, if you check on the left side, the fluid displaced side, do you see that the volume of the fluid that was displaced is 2 liters, right? That was 2 liters. And if you weigh that water that was displaced, it's equal to 19.6 newtons. And coincidentally, the value of upthrust on the object is also 19.6, the pink arrow, right? So the pink arrow, the value of upthrust on the block is equal to the weight of the fluid that was displaced. That's basically what upthrust is. The upthrust, Archimedes' principle is that, in fact, let's change the values a bit and make it even more. Okay, now check it out. I keep on, okay, now check it out. Again, as I've increased the weight, the upthrust is larger. Okay. And the upthrust is larger, which means the weight of the fluid that was displaced is also increasing, right? Because you increased, let's, take a different example. Yes. Now, upthrust is equal to 3.3 Newton. And we notice on the left side that the volume of the fluid that was displaced is 3.4 liter. And if you take and measure and weigh that fluid that was displaced, it is equal to the value of upthrust on the block. Okay, so that's basically Archimedes' principle. Okay, yes, questions. Takes a lot of imagination to understand this, but it is very, very important to understand it. Yes, guys,
In
questions.
these questions, would they give us like the volume displaced? Or would
Yes,
they
they will
just give
give
us
you.
like the initial volume and the final volume?
Yes, don't worry. We have all of those questions over here. They'll tell you everything. It's a bit difficult to understand this, without solving questions because it's very difficult to, know which value will be given, which value will not be given. It'll become more clearer in the question. But most of the time, what they'll tell you is they will ask you to figure out what is the upthrust on an object. Okay. So then you just use this formula, density of fluid times G times VF, right? Now, the trick they do is that rather than giving you the volume of the water that was displaced, they say that only 68% of the object was submerged. Okay, only 68% was submerged. Now that's where things get tricky, and you can't exactly use the volume of the fluid that was displaced, right? So that means you will have to somehow, work your way around the question to find out what would be the volume of the object that was submerged, then plug it into that formula. Okay, it is a slightly complicated topic to understand without have solving the questions. Okay, but for now, what I want you to do is, make sure you've written this down. Make sure you've tried to get your head around it. I will send you a video as well. I'm sending it to you right now. Make sure you watch it after class. It's a really good explanation without all the complicated maths, and it's explaining exactly this idea, Archimedes principle. That is what upthrust is, or we also call it the buoyant force, and it's a really good demonstration by Khan Academy. Okay, sounds good. Now we figured out what the value of upthrust is, right? So upthrust is equals to, we use only these two formulas: density of fluid into G times volume of the fluid that was displaced, or F upthrust is equals to mass of the fluid displaced into G. Okay, what these formulas mean is very important. Why? Because that's where most students get confused. They're not sure whether to use the density of the fluid, density of the object, or weight of the object, weight of the fluid, right? So that's why, in fact, write it down. This is the mass of fluid displaced. Okay. And rho F is density of fluid. Make sure you remember that. It is never density of object, density of fluid. Now, VF means two things. It is the volume of fluid displaced, or extra fluid, or or it is the volume of object submerged. Submerged, not the total volume, right? If the total volume is submerged, then you'd use the total volume. But if only half the volume is submerged, then you'd only use half the volume. Okay, sounds good. Now we figured out what the value of upthrust is. Now we are going back to our original question. What is going to determine whether objects float or sink? Hmm. Yes. No, you know what? I'll stop here. Okay. You've already got the test ahead of you as well. I'll stop here, and you can try to wrap your head around this. I would recommend that you watch the video after the class. I'll send it to you in a bit. You can watch it after the test. Write this down, try to understand this, watch the video, use ChatGPT to understand it. It will, there's not much I can do for you rather than, push you in the right direction. I will send you the video, watch it, write it down, all of this. And if you have any question, you can text me at any time. Okay. So we'll stop here up till this point, and we'll figure out the rest in the next class. In the next class, all of the dots will start connecting together, and it'll seem much easier. And we'll also do past paper questions, which will help you to understand which concepts are very important, and which concepts are just building up the concept. Okay. Now I am going to send you the test right now. Okay. And you will have 1 hour and 30 minutes to solve it. I don't think so it would take you 1 hour, 30 minutes. I think you'll be done in like, 1 hour at best. If you've practiced enough, you can even solve it in like 45 minutes. Okay. So I have already sent the instructions as well, right? You can print it if you want. You can solve it on a notebook, but make sure you write down the question number exactly as it is shown and send it as a scanned PDF. Okay. Yes. Any questions? Yes. All good. Should I send it? Okay. Hania, by the way, you have already done it, so you're free to go. I'll send the video. You can do that instead. Okay. I'm sending it in the group.